This project was about 160 some odd thousand square feet. We were awarded the license to start building in December 1st, 2012. And from that point until groundbreaking, we had about 4 months to get underway with the construction. The project, of course, was fast-tracked. It went out in multiple packages. It involved a lot of different coordination among many different disciplines. We, as a full-service company, have structural, mechanical, electrical, plumbing with in-house, a lot of different disciplines. On this, we were actually working with many outside consultants as well. We've looked at our BIM toolkit, not just as your traditional modeling and building process, but we've tried to look at it across the whole platform of what we do. So not only are we doing it on the construction side, we're doing it on the visualization side, the pre-planning, which we do an awful lot of. These are some of the early site plans. I think at last count we had, before we finally reached the last design, about 24 different massing and site solutions within the short period that we have. Once we did achieve the final design, we had to integrate our project with a lot of different disciplines and softwares, not just one, Revit or Navisworks or something like that. While Revit is one of the bases of our platforms, we certainly, with our Civil, have Civil 3D. We've still got AutoCAD out there. We had our structural engineer working in Tekla, which we had to coordinate with. And we have to bring all those different pieces together. We did a lot of early visualization with massing models, of course. And all of this is part of the design process that we go through, from simple massing to finished renderings. And this is kind of our normal process. We find our clients very demanding in that respect, and they want to really know what the project's going to look like before it gets done. So for us, we've taken BIM from just the modeling and technical aspects of construction to even the visualization side of what does the furniture look like. Color is very, very important in this particular field. So we have incorporated all the paint catalogs into our visualization process, our modeling process, and we've really streamlined our visualization through going from Revit to 3D Studio to V-Ray to a lot of different software, so it's a pretty efficient process at this point. We can knock these visualizations out pretty darn quick, and I used to do a lot of freehand rendering. I don't anymore because this stuff's faster. Just kind of the way the state of the art has gone. Once we got into the construction part, this presented some unique problems and challenges. For those of you that might be familiar with it, the gaming floor there in the middle is a 45,000 square foot floating barge. So not only do we have traditional architecture, we've got a barge sitting in a basin, big swimming pool, it's restrained and floating. It's all concrete. We had to coordinate a 42,000 square foot single pour of concrete that was then post-tensioned in 24 hours. So we had the structural engineer on site doing that, and the structural engineer coined a term that I like to use, and I think it's really good. They don't just do BIM, we do high definition BIM. So they had the model put together with the structural. You can see the incorporation, all the bits and pieces there, such that the engineer of record, the structural engineer, could do the shop drawings more expeditiously than a third party. So they were brought on board to actually do the shops and coordinate the final steel work. You saw a couple of different studies there for the canopy truss. We went through several different designs. Another part of that was that we had to incorporate some existing steel we already had from a past project. So as we were working through that, the structural model was coordinated with different colors for the bits and pieces of steel that the owner owned, and we were trying to use up in the model as well as the new steel we were doing. We do a lot of Navisworks walkthroughs as part of the presentation process. These tend to be fairly simple, but I think very informative for the clients so they can really see what it's like to move through their building as kind of a final sign-off, here's the design. Of course, we do a lot of the slice and dice for areas and square footages, and certainly in the planning process, one of the easiest ways to control our cost is to control that square footage in that program. And I think BIM is certainly a good tool for that. When we get to our schematic, or excuse me, our construction drawings, We're modeling an awful lot of this. The majority of what you see here is actually 3D modeled, a lot of complex geometry. We've got a lot of talented staff now. They're very good at this. And you can see that not only do we get the 2D drawings, but of course the 3D drawings that are being incorporated into our construction drawings, which are very helpful for the contractors as they move into that final design. So while instead of just graphing out some details, we tend to model it as opposed to just throw it in a 2D sketch or an overlay or something. As we go through, our design process really never stops. So as we're kind of refining the designs and going through, we'll do sun studies, color studies, renderings, any number of different types of drawings as we go through all of this. As I said, we've got full in-house for electrical lighting and so forth, so we have other programs for lighting analysis, our heating calculations and so forth that we also apply to this. And certainly I think the test is, what can you go from in terms of the model. You can see the detail of all the elements. This is not the photo, this is the rendering. And then the finished product here in a sec. There you go, the finished product. You can see several of those. So really the challenge for us has not just been one piece of software or kind of one focused task, but really managing a whole variety of information from the building model itself, schematic design, massing, through the construction drawing, where our design process really doesn't stop. And I think that's been one of the big advantages for us, is this is a very fluid market that we're in, and the client is constantly changing, making decisions as we progress, and we want to be flexible for the client to make those changes as we move down the road. So there were lots of design decisions that were made at this level, the rendering level, presentation level, and we could go back and forth without really losing anything in that data stream from the schematic and concept through to the final presentation. And that's really been important for us. So, instead of going from SketchUp or something loose, we can go into this sort of rendering detail for the final product and have a very clear presentation of our client of what that's going to feel like and look like in the end process. So for us, it's been I think a broader view of building information modeling, and we've taken that with this project and other projects to the shop drawing process and review process. So it's really a team collaboration. We're trying to integrate with teams like S.M. Wilson, which they had our model, working through the shop drawing process to expedite that. This had about a 14, 16 month construction period, and some fairly complicated structural systems, mechanical, low voltage systems that went into this. So that's a lot of coordination within a short period of time. I'd like to be able to say, like some of the others, that, oh, we planned it all out ahead of time, but given the short compressed time frame, that's not necessarily possible. What BIM does for us, of course, is lets us pre-plan and avoid a lot of the pitfalls that we might find. So while this went out in a fast-track fashion, we had many different packages from the subsurface foundations, the superstructure, the exterior shell, the interior package, the FF&E package, a lot of different packages as we pulled this whole project together that were going out as the project was progressing. We were able to keep that better coordinated and manage the change better, which I think is the big advantage for us. Change is going to happen, and especially in a fast project like that, that's going to happen, but we can manage it much better. And I think just the visualization process, being able to capture some of the details, here's some of the structural that we're able to expose and integrate into the project, and it's just a better collaborative process for us. As we get into some of the final images, we do a lot of color studies, and as I said, we really try to get that on point when we finally present that to the client so that they're sure that the product's going to look the way they want. These are just a few of the final images of the completed project. So a lot of different systems, as I said. Probably the biggest challenge was on the structural side. We're in the new magnet fault system, so we had several unique systems there. Not only a superstructure that had to resist the earthquake, but also the basin. We've got a boat sloshing around in a big bathtub. Some horizontal buttresses, And to get that all coordinated, especially between the mechanical, electrical, and the structural system integrated so that they aren't putting holes in big chunks of concrete was quite a challenge. So just a few of the last images of some of the exterior buildings.